All right, well, I think we'll go ahead and get started. Hi, everyone. Thank you for joining us on this Wednesday workshop. For those of you who aren't familiar, my name is Katie Schwartz, and I am the training program coordinator here with Colorado LTAP. We provide these Wednesday workshops during the off seasons just to talk about some of the latest and greatest innovations in the transportation industry. Just a couple of quick housekeeping items. If you're not speaking, please try to keep yourself on mute just to prevent any interference. And then as one quick disclosure, Colorado LTAP does not endorse products, manufacturers, or outside entities. This presentation is for informational purposes only and are not intended to reflect a preference, approval, or endorsement of any one product or entity by Colorado LTAP. I think that's all the kind of nitty gritty I have to get into. So today we are here with Valmont Bridge Systems. And with that, I will go ahead and hand it over to them.
Thank you, Katrina. I will share my slides and let Jeff do the first half of this presentation. Working on it. 1 second. Screen. Okay, how's that look, Jeff?
Phenomenal.
All right. Take it away.
Afternoon, everybody. My name is Jeff Simpkins. I'm the National Sales Manager for Valmont Structures Press Brake Tub Girder Division. With me is Guy Nelson. He's our Product Development Director. Also, we have local support in the Colorado area. Kelly Cadell is on the line, and she can say hello as well.
Yeah, I'll just say a quick hello. I'm here in Denver, Colorado, and hopefully you guys hear some stuff that you like, and I look forward to working with you.
Between the three of us, we will update you on our proven and established technology. Not mine, but anyway, talk about the press brake tub girder that we fabricate for bridge beams. I always like to start with a little bit of information about Valmont as a company, because within our bridge community, Valmont is not really well known. It's only been recently that we've had a product offering for the owners and roads and bridges that we cater to. But Valmont started as a steel fabricator in 1946. Fast forward to now, Valmont is a global leader in the engineered products and services for infrastructure, so lighting, traffic, and sign solutions, as well as the tub girder that we're here to talk about today. Valmont is also an AISC certified intermediate bridge fabricator, and there aren't a whole lot of us out there, but that gives us a lot of credence in the market to fabricate a reliable, quality, standardized product for the owners that we cater to. So I'll back up a little bit and ask the question aloud. Why do we need another bridge beam out there? There's lots of them already to design around. Why do we need to add yet another to the mix? This is some data that we got from Michigan DOT, and what it's showing is that many of their concrete structures are not getting to the 75-year service life requirement that AASHTO has baked into their bridge design requirements. And FHWA's ultimate goal is to provide a 100-year bridge out into the field, and we have achieved that, or this non-proprietary open source design has gotten very close to that. And I'll also add that most of the lower 48 states are seeing some similar version where the beams are just not getting to that 75-year service life. So here's our solution to that kind of chronic problem, but this is a good blowout of what a press brake tub girder looks like. And what it competes against is a similar depth of structure bridge beam, which might be a deep slab concrete bridge, an I-beam of some sort, or a concrete box beam. But with this design, we can accommodate spans anywhere from 20-foot clear going all the way up to about 95-foot clear under HL93 loading. This past year, the press brake tub girder was given a lot of momentum from the AASHTO community in that it was chosen as their innovative award winner of 2021, and we're promoting it further this year. But what that means to you is that AASHTO has looked at this particular design over the last few years, and this is their official announcement that, in their words, this is ready to implement technology, not only for any DOT, but for any owner out there. So counties, cities, the like. I mentioned that this is an AASHTO design and it's open source and non-proprietary, but it's really been the SSSBA and the two fellows in the lower right corner, Dr. Barth and Dr. Michelson, that have championed this design throughout the bridge world, but it hasn't come without a certain amount of work. In fact, the SSSBA has a 7-volume research report, and they've done this research over the course of the last 10 years to come up with the design itself and all the data to back up what we're going to talk about today. But long story short, use the SSSBA as a knowledge resource for not only press brake tub girders, but anything steel design. This is the first press brake tub girder that we know of that has been installed, and this was done back in 2004 for the Monroe County Road Commission. So we have 20 years of installations to draw upon, anywhere from this one to just a few that we've done last year. But as a result of this first installation, Monroe County now has 5 in their inventory, and that's usually how things typically flow, is where we can, during the design season, they will reach out for a press brake tub girder design, but because there are advantages for not only the owner, but also the consultants and the contractors of the world, they end up using one that next season. So we have a really good inventory of these in Michigan, Texas, and then kind of onesie-twosie throughout the states. None of this happens without fabricating. And prior to the Jasper, Tennessee facility that you're seeing here, we were fabricating out of our corporate office in Valley, Nebraska, but we have received so many requests for tubs that we really needed this purpose-built facility to just do tub girders. And we had our grand opening last August, but if anybody is in the Chattanooga area, you're welcome to come down and see the entire process. It's really neat to see this start as a piece of discrete plate, and down the bottom of that garage door, a fully fabricated press brake tub girder comes out the other side. So you're welcome to join us anytime. Here are the different stages of at that facility in Jasper, and you can see that we have the largest press brake in the world at 60 feet. That's that picture in the upper right corner. Right next to it is our cold rolling cambering machine, how we build camber into each one of the tubs. But it's kind of it's a very simplistic fabrication facility. There are only a few stations that take it from that discrete plate and turn it into that tub girder. There are 5 steps that we take in the fabrication of a press brake tub girder. I'll go through each one of these briefly. Also talk about the oversight that we follow for each one of these steps too. It all starts with this discrete plate. This is AASHTO M270 grade 50 plate, and we use a 3/8 plate thickness across all 5 sizes. And we do that to ensure that we're maintaining the same bend radius across all 5 sizes as well. You might be wondering why we chose Jasper, Tennessee. It seems pretty remote, but all of our steel suppliers are kind of in that Rust Belt Midwestern area. And rather than try and ship that discrete plate, which is pretty tough at times, to wherever we wanted to fabricate, the suppliers are there in kind of that Tennessee area. And it's a whole lot easier to ship the tubs fully fabricated. In fact, you can get up to 6 on a single truck. So it's a whole lot easier to ship it as a tub versus that discrete plate. Here's our press brake. This picture just gives you a good idea of the different size. So the press brake is 60 feet long, and with tooling, it yields a 57 individual foot long piece. ASTM allows for a 2.25 T bend when we're bending the base material, but we actually follow AASHTO's much more gradual 5 T bend directive, and we do that to ensure that we don't fracture that base material during the bending process. That also allows for a category A base plate fatigue detail, although we use a category B fatigue detail in our Valmont design standards just to be conservative. This is a good cross section of a press brake tub girder in kind of a testing phase, but you can see that 5T bend in the base steel. One of your takeaways from this presentation should be, although we are bending the steel and turning it into a press brake tub girder, there's no fatigue critical aspects for you as an owner to inspect once these are placed in service, because it's just a piece of bent steel. So we understand that you would like to inspect tubs, and you can do that with the inspection ports that are on either side of each tub, but there's really nothing to inspect once the driving surface is placed on top. The tub's interior really becomes an enclosed environment. Here's another picture of that cambering machine that we have. This is an automated setup. There are optical sensors on the machine itself, so it's constantly measuring the camber that we're building into the tubs. And we camber the tubs for a couple of different reasons. The first is to accommodate that dead load going on top, but also to mirror or improve on the vertical profile of the bridge that we are replacing as well. And we have the ability to be measuring that camber constantly, so we know how much to put in and also when to stop. Here's a good picture of the automated stud welding machine that we use there down in Jasper. And the shear studs are shop applied, but really this is a value add to the contractor that probably doesn't want to do any field welding. Because we take this on ourselves in the shop, it yields a much more consistent, repeatable product. But probably the most important step is to take this black steel and galvanize it. We galvanize to ASTM 123, so that's less than 2% rust that can show up over a 75-year period in a marine environment. And I think that owners are kind of trained that every 40 to 50 years, they're going to have to replace either a superstructure or an entire bridge. But because the coating, because that galvanization on the steel lasts 75 years, let alone the steel underneath, owners are able to leapfrog that 40 to 50 year window and get a significantly extended life out of this bridge being comparative to some of the stuff that you might be more used to designing around. This is not a Valmont bridge, but the Stearns Bayou Bridge was installed in 1966. And up to this point, there's no known maintenance that's been done to the bridge, but Valmont recently went out and did a coating thickness test and found that on average, there is still 4.7 mil of galvanized material on the steel. And even in the low spots, there's still about 2.9 of that galvanization remaining. And if you forecast out the balance of service life, you can estimate there's an additional 50 years of service life, where competing designs that had been installed around that same time frame are probably not faring nearly as well. In fact, they've probably already been replaced. So just a good testimonial to galvanizing when you can. Now, if you are opposed to galvanization, we can do a 3-coat paint system on the tubs instead. We can also do weathering steel if that is your preference. At the end of the day, we are coaters by nature. So whatever it is that, whatever coating that you would like on the tubs, we can provide. But galvanization seems to give the best bang for the buck. That is the lowest upfront cost with the longest lifespan attached. So our preference and the default is typically galvanization. So a quick summary of our 5 steps to fabricate. Anybody got any questions? Everybody doing well? Okay. So if you wanted to design your own press brake tub girder, here is the roadmap in AASHTO's design language that you would take to get from start to finish in terms of design. And if you notice, this is following 611, so that's a flexural box member in AASHTO's design language. But if you didn't want to do that initial missionary work, we've come up with 5 different sizes of tub that cater to the span lengths we think are most often going to be replaced. And that is everything as short as a 20-foot clear span, going all the way up to that 95-foot clear span under HL93 loading. Now we can accommodate a higher loading criteria that just kind of limits what that ultimate span length ends up being. But this can be modified for not only any loading criteria, but pedestrian loading as well, also rail loading too. Now, if you're looking at that drawing in the upper right corner, you see that D value, that's that depth of structure. That's really the only thing that changes. The footprint of the tubs, all 5 tubs stay pretty close to the same, except for that D value, that depth of structure. We have everything as shallow as a U12, and we go up in 6-inch increments to a U30, and then also a U33. And those 5 sizes span that 20 to 95 foot clear. Now we publish what we call a tub selection diagram, and that's that chart kind of in the center on the left, but pretty quickly you can figure out at what span length and what spacing, which tub that we would suggest. Now this is the most efficient solution that I'm giving you, but oftentimes that vertical profile or depth of structure drives what you're going to use for bridge replacement. And like other designs, you can use a more shallow tub, but then use more of them across the width of the bridge if you would like to have a minimal depth of structure instead of the most efficient solution. Here are the 5 sizes for your reference. Also, I can forward anybody that has any interest, I can forward our catalog as well as our design guidelines if that's helpful, and that gives you everything, all the content of this presentation too. So our longest single piece is 57 feet, but I also told you that we could accommodate up to a 95 foot clear span. And the way that we do that is with this bolted connection that you're seeing right here. So anything over 57 feet receives either 1 or 2 bolted splice connections that you're seeing here. But there's no further surface prep that a contractor needs to do once these are assembled in the field. This is has a Class C slip critical surface condition at bolted connections. So no further surface prep that contractor needs to do. Typically we ship them in their individual components because anything longer than 57 feet is a permit load or some kind of specialty load, and that raises the overall cost of shipping. So we typically keep them in their primary components, let that contractor assemble them in the field, and they know how to put nuts and bolts together pretty well. For every project, Valmont produces fabrication and inspection shop drawings from the approved bridge plans, and all of the details include plan and elevation view like you're seeing here, tub girder cross sections, studs, internal and diaphragms, internal lateral angle braces, and camber. And I mentioned that we build camber into every single tub, typically both for dead load and also for vertical profile. Here's a good picture of a tub girder, and once it's been placed in service. And I always get questions about inspection, but again, there's not a whole lot to inspect once these have been placed in service. It's a lot of visual cues. You're looking for any chalkiness on the galvanization that would be representative of any standing water. But once they're placed in service, not a whole lot to look for, but I understand that you need to inspect all of your bridging, not just the stuff that might be problematic. With that said, there are inspection ports on either side of each tub. They're 12-inch holes, it has limited access. You can see that door that goes over the top. You don't want any critters getting up in there and living, but we also have 2 2-inch weep holes on either side of each tub too. So if any moisture has gotten inside through the deck, it will drain naturally towards those inspection ports or the weep holes. Remember, we have a little camber built into each tub, so the high spot of each tub is in the center, so anything will drain towards those weep holes. Texas is another state that has quite a few press brake tub girders, and these are just representative of the current inspections that are going on at TxDOT. And maybe you can see, maybe you can't, but most of these are rating quite well at a rate of 8 out of 10 after 13 years, so aging well. So once you understand the tubs, the next logical question is what are your choices for driving surface? And really, you've got a couple. I think every project comes down to either time or money, which is driving that project ultimately. With that said, we are seeing contractors choose about 80% of the time a cast-in-place deck as opposed to a precast deck. And this is what a cast-in-place deck looks like in practice. You can see the 2-inch stay-in-place metal decking that is going over the top of the tubs to keep them voided during the casting process. And in this example, they have stay-in-place metal decking that's going between the tubs as well. You can use, depending on the state, what Colorado's requirements are. You can use wood forms between the tubs, but then you have to strip that off, and it comes down to what does that contractor want to do? Put one thing in just across that might be a little more expensive, or try and save some bucks by using that plywood between. But that constitutes the bottom form of your cast in place scenario. And then you would just form up the sides as you would with any other bridge beam to cast that deck in place. Now, we also have the capability to add any hardware, any steel hardware to the outer tubs to make this casting in place a little bit easier for the contractor. And we can add that prior to the galvanization. A lot of times we can provide it for them. We just need to figure out what they would like to do and how we can speed this process up for them. But any half hangers and any other kind of casting hardware we can add to those outer tubs prior to galvanization so that they don't have to do any field welding and they don't have to weld on that galvanization. If precast is driving, if your speed of installation is driving the project more than that overall cost, here's a good example of what a precast deck looks like. This is a longitudinal pour, so it follows each one of the tubs. So it's just a matter of setting those tubs on the bearings and then doing a closure pour of some kind between those panels to make that driving surface complete. I mentioned that Guy Nelson is our product development director, but he's also been installing these for the last 20 years now and has a lot of good real world information, maybe some soft costs and other benefits that you might not be recognizing. So he's going to take it from here. Take it away, my friend.
All right. Thank you very much, Jeff, for the detailed description of what a press brake form steel tub girder is, or what we at Valmont, we like to call it our U-beam. I have been designing, installing, and now fabricating press brake tub girders now for almost 20 years. I was involved in that first project that Jeff showed you earlier, that Monroe County Road Commission project. I worked for URS Corporation at the time, and was on the design team that designed that first press brake tub girder. So back then, we really didn't know how it really fit into AASHTO, which is why the Short Span Steel Bridge Alliance, we like to promote all of the work they have done to really make this this product, this beam, standardized in their volume, in their first volume. They show that these can be designed per AASHTO section 611 as a flexural box member. So with that, the picture here you can see in the background, that is the fifth bridge in Monroe County Road Commission's inventory. So once they did that first bridge, they inspected every 2 years, are very happy with the product, and now 20 years later have 5 in their inventory. I'm going to talk to you about a couple other agencies and some other example projects that we have done with press brake tub girders throughout the United States. So the first one I'm going to talk about is Champaign County Road Commission in Illinois. They have now a few of these press brake tub girders in their inventory, and they actually present about this. This was actually a presentation they gave in 2019 about the different bridge types they have in their inventory and what the advantages are of the different types they use. And also what they like to call their bang for their buck that they get for each bridge type. So you can kind of see here the different, the 4 different bridge types they use on their inventory. The one on the left, the cheapest one, the precast box beams, side-by-side box beams that are their most cost-effective product. But however, they agree they only get them about 50 years of service life. So right now, currently, Illinois or the Champaign County Road Commission replaces 8 bridge superstructures or bridge replacements a year, and their goal is to use longer lasting products and get that down in the next 20 years. They will only want to replacing 4 a year. So they talk about the bang for their buck in the fact that they want to use products that give them a longer service life. And you can see over to the right, that's our product, the galvanized press brake tub girder with a concrete deck. It comes at about a 20% premium. However, it gets them double the service life. So if you look at that as far as lifetime value, or as Champaign County would say, bang for your buck, you're getting a much longer service life out of that product and much more value for your upfront dollars. So they then look at that as a cost per square foot over the lifetime. And Champaign County would say the most bang for their buck they get is for the galvanized press brake tub girder. The next project I'm going to talk about is another project in Michigan. Was for the Michigan Department of Transportation up in Grand Traverse County. So this was a project that was designed by OHM Consulting. So at Valmont, I'm an engineer. We have an engineering staff called our ESS group. However, we are not bridge engineers. We're not the engineer of record for bridges. We can help facilitate the engineering and the design of our U-beams. However, we like to get the information out there and let the consultants do their jobs and design the bridge themselves. For in this particular project, it was designed, as Jeff showed you earlier, as one of those precast deck bridges. I like to call them PB, or FHWA likes to call them PBU units, the prefabricated bridge units. So this was designed as a PBU unit for an ABC type application. This was a 2-span bridge, 2 55-foot spans. All those PBU units have to be tied together with closure pours. We call them, usually they use ultra high performance concrete, which has to be mixed in the field and is very expensive. So this project was designed by OHM and then went out for letting. The low bid contractor chose to value engineer out the precast concrete deck. So in this contract, there was, in the proposal, there was a VECP clause where the contractor could give some money back to the owner and change some of the elements of the bridge. So they chose to change the precast concrete deck to cast in place and give back a little bit money to the DOT. So with that cast in place deck, remember I said this was a 2-span bridge. It was designed as 2 spans, as simple span for dead load and live load. They also had an engineer redesign that bridge deck and make it a continuous for live load bridge deck. So with some negative moment reinforcement, you can see there in that typical pier diaphragm. So kind of belt and suspenders. The chart that Jeff showed you earlier, our beams are typically designed for simple span for dead load and live load, but you can always make them continuous for live load with a cast in place bridge deck. So I'm going to show some slides now of the actual construction process. So here is the installation of those 12 U-beams. So there were 6 U-beams in each span, without the concrete, because the contractor value engineered it out. All 12 U-beams showed up on 3 standard size truck trailers. We can get as many as 6 U-beams on a truck, but in this case, because of weight limitations, we delivered 4 U-beams on each truck, and all 3 of those trucks showed up to the right side. So on that picture on the left there, that's looking north. All 3 trucks showed up to the east side of this river, and then the contractor was able to set all 12 beams from that same shore. So if you think about typical concrete construction, concrete beams, our beams weighed about 6,000 pounds each. Concrete beams would probably have been more like 50,000 pounds each. And usually you get those delivered one at a time on a specialty trailer. And then then that crane picks one up at a time and sets them onto the span. And they also wouldn't have been able to do all 12 from one side. They would do 6 from that east shore. They'd break down the crane and move the crane around to the other side to install the 6 beams from the west side of the river. This is a 20-mile detour around this. So the contractor estimated it saved him about 4 days of work where he didn't have to move his crane to the other side of the river. So very quick installation. You can also see in that picture that what I call the fascia brackets or fascia jacks that are installed on those fascia beams. As Jeff said, we give the contractor the hardware so they can easily install those fascia forms and then put them over or onto the beams before they put it over the river. So that same day, I took some pictures there in the bottom right picture. They were already putting that metal decking that Jeff showed you earlier. They were already putting that metal decking on the beams that afternoon. So the installation goes very quickly. I do want to mention, as Jeff mentioned before, we don't always have to do the steel stay in place metal decking. We have done bridges, as Jeff showed you, down in Texas, where the standard in Texas is for a precast pre-stressed slab that is a stay in place form. So if you could just imagine, instead of those metal pieces being put on our beams, there is a 2.5 inch concrete panel that's put on the beam. So different states allow different things, and we can accommodate however that might be. So here is that 2-span bridge being cast in place the next week. So we delivered the beams on a Tuesday. This is the next week, Thursday. I went back up to the job site, and they were already casting the bridge deck, that 2-span bridge deck. And then in Michigan, we're required to have a 7-day wet cure. So really, in 2 weeks after delivering the beams, they already had the bridge cast and were able to open that bridge up to construction live load. So it goes very quickly with this system. The form work goes in very simply and quickly. And here is the picture of that final bridge product that is over the Borgman River. That is a top 10 trout stream here in Michigan. So it's very important for the DOT and the county to make sure that stream is protected for any runoff. So also, if you see those bridge railings, there is a curb underneath those bridge railings, and that curb collects the runoff from the roadway. Any chlorides, we use a lot of salt in Michigan. Any chlorides collects that runoff and then runs it into the drainage system on the approaches. So overall, a very good looking bridge. The DOT and the county was very happy with the final product. Next job I'm going to talk about is a project we just installed in Imperial County, California. So this project was designed, this is our longest span bridge yet. It's a single span bridge, and it's 92 foot long. It was designed to replace a 3-span bridge. That was actually the bridge that is out there, or was out there, was actually subsiding into, it goes over a drainage canal, and the existing bridge was subsiding into that drainage canal. So they needed to have 2 things. Because of the subsidence, they were worried about the new bridge also settling, and they wanted a very light bridge system. They also wanted a very shallow depth bridge system. So the press brake tub girder option, the U-beam option, gave the consultant on this is NV5, gave NV5 the option they wanted to have a very light superstructure and a very shallow depth superstructure. So one specialty or one occurrence on this project that shows the versatility of U-beams, this bridge was designed as a cast in place concrete bridge deck. So it was designed for the U-beams to go out there and be set over the channel, and then them to pour that concrete deck in place, like you saw on the like I showed you on the Traverse the MDOT Grand Traverse County project. However, we delivered the beams to the job site, and the utility workers, the utility company, was still relocating a water main that was in the way of this bridge. So the contractor received the beams, but they couldn't work on the job site yet because the utility company was still working. So as you can see in these pictures on the top, the contractor decided, well, we're out here, why don't we just precast the concrete bridge decks? They knew that was an option to them. And so they chose, and it was approved by the engineer, they chose to do a precast concrete bridge deck. So kind of opposite of what you saw in the previous project. They received the beams, then they actually precast them in the field right there. Well, it was really a parking lot right there next to this bridge project site, and then used a crane to then lift them and set them into place once that utility company was out of the way. The contractor estimated that saved them 4 weeks on the construction schedule because of the delay, they were able to do all that concrete work ahead of time. And then you can kind of see in that bottom left picture there, they finished it, did the closure pours, and actually they ground the bridge deck and those joints after they set it on the bridge. So again, good, cool application, shows the versatility of press brake tub girders, that you can do a PBU unit right on the job site. Another project I want to talk about is a emergency bridge replacement project we did just recently for the Tennessee Department of Transportation. So this bridge was actually designed by the Tennessee Department of Transportation. It was designed as press brake form tub girders. They wanted to replace, I don't know if you all remember, but early last year in the spring, there was a lot of big flooding in both Kentucky and Tennessee. They had a lot of bridges washed out in both states. They wanted to get this bridge replaced as quickly as possible. So they contacted us and said, how fast can you deliver a press brake form tub girder? And we let them know, well, depending on their schedule, we should be able to deliver it in 6 to 8 weeks. So a lot of times steel gets a bad rap for being a long delivery time or a long lead time item. For us, that's not the case. We can, as Jeff showed you, we have a plant that is dedicated, fully dedicated to just fabricating press brake form tub girders. So we can, our typical lead time is usually, we tell people 10 to 12 weeks. However, in emergency situations, we turned around bridge beams to Tennessee DOT in only 6 weeks. And so the whole bridge was then able to open with in less than 3 months. So the DOT was very happy about the speed of the construction. And also they are now incorporating press brake form tub girders into their standards that they have for concrete beams and steel beams. So another good reference to an agency using press brake tub girders. And then the last project I'm going to talk about is our latest project where we did a bridge bundling project. So bridge bundling is kind of a new thing out there. Everybody's trying these, trying to save money or make better use of the money they have by bundling bridges. So in Michigan, if I didn't say already, as you probably can tell, I am in Michigan. I'm designing bridges, or I am still located in Michigan. I have designed bridges in Michigan for about 15 years. So back in 2018, Michigan elected a new governor, and her pledge was to fix the roads. In her own wording, she said it that way. But the big thing was, so right away, she looked to the legislature to get more funding by proposing a gas tax, which was rejected by the legislature. So she looked at, well, what are other ways? The governor and the Department of Transportation looked at other ways of doing more with less. And they decided to do that by a pilot bridge bundling project. So they chose 19 bridges throughout the state and did it as what's called a design build contract. So the DOT didn't design these bridges. They put out a request for proposal for contractors and consultant teams to not only rebuild these bridges, but also design them in the contract. So 5 teams were shortlisted to bid on these projects. They were shortlisted by the DOT to bid on these projects. Valmont, we gave all 5 teams, remember these bridges were not designed yet, but we knew the spans that were required for each bridge and the number of spans and the length of the spans. So we gave, using those design guidelines that Jeff showed you, using those design guidelines, we gave all contractors our options for the superstructure beams for all 19 bridges and the pricing for all 19 bridges. So contract was awarded to a team of CA Hull Construction, Anlon Construction, and Alfred Benish Consulting was awarded to that team who was the low bidder for this project. And that team chose Valmont to provide all 157 bridge beams for the project. So that really surprised us. It was we had never worked with CA Hull, with Anlon, or with Alfred Benish. So on a very high profile project in Michigan, you might think, well, why would a contractor choose a new vendor? They'd never used us before, and a new product that they had never used before. So I'm going to go through some reasons of why CA Hull Anlon chose to use our product. First thing was the innovation of it. They realized we gave them solutions. We have a big engineering staff. We are not bridge engineers. We are steel fabricators and engineers of steel. We gave them our engineered design solutions for all 19 bridges. So Alfred Benish could then incorporate them into their own plans, into their own construction plans. So not only can we design them, we can also do load ratings if that's also required in the project. So we have an engineering group that can design the U-beams, we can provide stamp designs, and we can provide load ratings for your specific state. So not only that, but these bridge beams save time. So one thing about this project, we were able to deliver 157 bridge beams all in the period of an 8-month construction schedule. So this project was let in 2021, but that first year was all the design stage. Really, the construction's years were supposed to be 2022 and 2023. Based on the delivery schedules we gave CA Hull and Anlon, and based on their construction schedules, they did all 19 bridges in 1 year. So we knocked off a total of 8 months. We did it all in 8 months, and we knocked a year off of the construction schedule. So huge savings for the contractor. And one of the reasons, how were we able to do that? Well, we were able to secure all 500 tons of steel in 2021. So once we had approved shop drawings, we had all the material we needed to go ahead and fabricate all of those 157 bridge beams. Another advantage was the efficiency of our plant. Again, to fabricate 100, and this was not the only project we did last year. I told you the Tennessee job was last year. We had a lot of other projects we had going on, but we were able to fabricate all 157 bridge beams and deliver them to the job site. So again, because of that big capacity of that new plant that Jeff showed you, we were able to fabricate all 157 beams, all in basically about an 8-month window. We had them all delivered by September of last year. Another advantage of them is that we can deliver multiple beams at one time. I talked about concrete beams and how usually concrete beams are too heavy, so you can only deliver about one at a time. We can deliver as many as 6 on one standard size trailer. They are very easy to unload. So normally with big concrete beams, you don't want a double handle. You want to pick it up and then set it on your foundation when it's ready. Well, in this case, if you think about having to manage 19 separate job sites all in one season, you don't have big cranes that to lift heavy material at every single job site. They unloaded with simple rubber wheeled equipment. You can see in the middle there, they use sky tracks to unload our U-beams and then put them on dunnage on the side of the road. And then if they had to, they could bring in a crane and then lift it out over where they needed it, or they could install it with some of these were installed with just an excavator. So very easy to, very light and very easy to handle. And then if you are picking up with a crane, you can simply use nylon straps. So your slings can be used with a nylon strap, and it can just be kind of barrel rolled around the U-beam, and it can be simply picked up at the quarter points. If you have another advantage is if you just have like a SkyTrack or an excavator, really these beams can be picked up right in the middle. Again, concrete beams, you can't do that. You need to pick them out at the ends. We recommend that the U-beams be lifted if you're doing it with slings at the quarter points. But if you just need to unload it off of the trailer, you can do that with forklifts right at the middle of the beam. So very easy to handle. And the last thing up in that picture in the upper right, you can see that's a 3-span bridge. There was 2 3-span bridges over rivers on this project. So on normal construction sequence, to install the beams in the middle span, say you had big heavy concrete beams, if you had to install the beams on that middle span, that crane that's sitting in that background, it would have to be put on a barge and floated out on the river, and then you pick the beams off of the shore and then put them into that middle span. The contractor on both bridges, the contractor was able to install them with that crane. You see that crane in the background. That crane installed the beams in the middle span. So they estimated it saved them on each bridge each of those 3-span bridges, it saved them about 2 weeks of work on each bridge, and about $500,000 total in cost, because they didn't have to get permits to be out on the river. They didn't have to bring in barges. They didn't have to bring that crane out onto the barge. So a lot of cost savings, a lot of advantages for the contractor. And then simply, once you get those beams set out onto your foundations, we talked about this earlier, very easy. If you're allowed to use stay-in-place metal decking, it goes on very simply and easily. You don't need to have the walking mechanism on, usually on I-beam bridges. You might have some kind of fall safety railing that contractors have to install. On the U-beams, you can walk directly down the middle. You can tie off to the bracing, and that is inside of our U-beams, so you can stay safe while you're walking inside of the U-beams. And it goes on very quickly. You can see there, you just lay the metal decking right directly on top of the of our U-beam, and then screw it down right to the top flange. Because our U-beams are cambered to both the dead load deflection and the vertical profile, we have a constant haunch. So as a contractor, you don't need to vary your formwork as you go down the bridge. You can just simply set it right on top of our top flange and go to it after that. And then finally, talked a lot of advantages for contractors, but what's the advantages for us, for engineers, and for our constituents, the owners of these bridges? And we like to say our beams are very cost competitive with other beams out there. I showed you the costs earlier in Champaign County, where it was a 20% premium. That is for the full superstructure. So, but for the bridge beam itself, we like to say we're competitive with all the other products that are out there. So if you're doing your own study, then you can use this dollar per linear or dollar per pound cost to compare it to other steel products. Structural steel is usually bid on a dollars per pound basis. So our current price is about $2.75 per pound. That's fully fabricated and delivered to the job site. Fully fabricated, galvanized, and delivered to the job site, including the studs. And that's delivered in a field splice manner. So the contractor would have to do the splice bolts if you need a splice on that beam. If you're comparing us to other concrete products, then concrete is typically bid on a dollar per linear foot basis. So if you take that $2.75 per pound for that fully fabricated and galvanized U-beam, multiply it by the weights of those 5 different shapes that we produce. So the U12, which gets you out, so it's a 12-inch deep beam, which gets you out to about 40-foot spans. That is priced at about $290 per linear foot, all the way up to the U33 that gets you almost to a 100-foot span. That is priced at about $430 per foot. So again, that's fully fabricated. That's with all the components you see here that Jeff showed you earlier. That's with the studs welded on and everything galvanized. That's with the inspection hatch covers that would cover that inspection hatch port. And then also with that splice, if it's longer than 57 feet, then it would also include all the bolts and the splice plates that need to be spliced in the field for a field splice manner. We can shop splice it and then deliver it full length, but that's not at that $2.75 per pound. Freight goes up exponentially if you have permit loads, and if we can't put 6 on a truck, if we can only put 1 on a truck, it really increases the cost of our freight. So $2.75 with a field splice if you need a splice. So with that, Trina, I'd like to kick it back to you and see if there were any questions, and Jeff and I maybe can answer any questions.
Awesome. Thank you, Jeff and Guy. That was great. Yeah, like you said, any questions from anyone while we're still here?
You want to talk about the inclusion of press brake tub girders to the Colorado standard?
Yeah, well, I can address it that it was added as an option. While there are not designed, you can come to us for any design guidelines or details. I think Colorado added it to their design manual, press brake tub girders, and that the selection chart, the beam selection chart is actually in the design manual. So again, if you want more information than that, if you actually want to design these and want details around specific details that you can design around, we can supply those at any time.
Yeah, and I'd like to just clarify on that. When he says it's in the design guidelines, that's for CDOT. So.
Yeah.
Right. Yeah. Thank you for the presentation. That was really insightful. I was wondering if this part had been used successfully on bridges with a significant skew for the support, either pier or abutment.
We've done so far up to 45 degrees. So the thing about skew, we are not limited. Again, these are designed by AASHTO Section 611 flexural box members. While there is no limitation on the skew per design, we can fabricate any skew and we can design any skew. You just lose some efficiency. So based on Section 611, if you have any skew at all, you have to assume it is not a compact section. So all 5 of our shapes, based on our proportion limits of each element, we are a compact shape. But if you have a skew, you have to design it as a non-compact shape. So for you engineers out there, I'm sure you know what that means. But basically, we lose about 10%, 15% of efficiencies because we can't design it for the moment capacity. We have to design for stresses. So yes, any skew, and we've done so far up to a 45-degree skew.
Any other questions from anybody? You nailed it, guy. Got them all.
All right. And on the screen, you can see if you have any questions, you can always contact myself, Jeff, or Kelly at MH Lighting if you have any further questions.
All right, awesome. And I don't know if everyone got a chance to take a peek at the chat. Just as a reminder and to reiterate what Bill said in there, Valmont does offer PDHs for this webinar. So if you want to shoot him an email or drop your name in the chat, you are welcome to do so to get a certificate. You can also contact LTAP and I'd be happy to pass along information as well. Bill and Valmont's contact information can also be found on our website for this event posting. Just another quick reminder, this webinar will be recorded and uploaded to the YouTube on LTAP. So if you want to share this information with anyone else, you are more than welcome to do so. Contact information for Valmont will be found there as well. And I think that pretty much covers everything. Big thank you to Guy and Jeff for coming and talking today, and everyone else at Valmont. You guys have been awesome. And I think with that, we can go ahead and sign off.
All right. Thank you, everybody. Thank you, Katrina.
Let us know how we can help.
Thank you.
Everyone.